I'm now going to talk about the second way to find a GCF, and that's using prime factorization. Prime factorization is helpful when you're using big numbers. So, I'm going to find the GCF of the same numbers I found in my first part, which is 18 and 48. So the way I'm going to do that is find the prime factorization of both numbers. So what I'm going to do is actually put 18 on this side, and I'm going to find the prime factorization of this one. So I'm going to put my branches, and I know 9 times 2 equals 18, and 2 is a prime number, and I need to continue on with mine. I know 3 times 3 are prime numbers, and both of them are prime, so I'm going to stop there. So for 18, I'm going to write that whole multiplication problem in order. 2 times 3 times 3, which is all the circled red numbers. Now I'm going to find the prime factorization of 48. I'm going to go with my tree again, and I'm going to pick any two numbers that get 48. And so I know that I can do 6 times 8. Both of those numbers are not prime, so I'm going to continue. I'm going to go and branch out 6. Two numbers multiply 6 is 2 times 3. Both of those numbers are prime, so I'm going to circle it to end my tree. I'm going to keep going with 8 and multiply 2 times 4. 2 is a prime number, so I'm going to stop there, but 4 needs to continue. And two numbers that multiply 4 is 2 times 2, and both of those are prime, so it's done. So now I'm going to write 48 down here, and I'm going to multiply this out 2, just like I did with the 18. 2 times 2 times 2 times 2 times 3. So 1, 2, 3, 4, 5 numbers, 1, 2, 3, 4, 5 numbers. Now, what I do next is circle the numbers that are the same top and bottom. Since there's a 2 on top and there's a 2 on the bottom, I'm going to circle those. There has to be a pair, a matchy-matchy. I go here in the 3, and I need another 3. There's 1, 3, all the way over here. I go to this 3. There's no other 3 that's free. So therefore, the only two numbers I circled that had a matchy-matchy or a pair, top and bottom, was a 2 and a 3. Now I'm going to write those out like it's a multiplication. I had a 2 and I had a 3. So multiply those out. 2 times 3 equals 6. And since I multiply that out, 6 is the GCF, just like the first example.